So we just discussed how to do a new measurement using the MikRIR utility. Let's talk about how to use it for plotting data you've already acquired. It's pretty straightforward, but I'll show you how to do it in any case. As I mentioned previously, I would tend to view the measurement phase as one workflow and the replotting and analysis phase as a second workflow. So to do the second of these, we can just launch the utility again. Which gives us this, and we don't care about measuring now. We're going to load a bunch of data. So this is the plotting window. It also has that WAV file export, of course, but you know about that already if you watched the previous video. If you load this fresh and you want to load some data, the first thing you need to do is click this switch, so it goes to the load side of things. This tells it that you are going to load some new data rather than measure some new data. Load some old data, sorry, rather than measure new data. Click the load tab, and you get a window here. So let's see the measurement. Let's load the measurement I just did, just to show you. Well, I did two of them, so I'll show you the functionality here that allows you to simultaneously load two files. So let's, I don't know, yeah, let's do that. And bingo, here we go. So it's ordered take 2 before take 1, but that doesn't really matter. That tells you what it is. This curve ID thing is assigned upon import to the plotter here. It's nothing to do with what's in the file itself. It tells you that it assigns a label here basically that's then used in the plotting, so you know which line is which. In some cases you might have many lines here and you need a unique ID for each line. So this summarizes the metadata that we spent some time constructing at the start, which is why we did it. So this is our room name, which in this case is a device characterization. We've got the source as the output, the receiver as the input, no speaker, and direct input 1 is the actual label for the particular mic. So in general you might have several mics, each of these with a different label, of course. And then the sample rate is noted here. So once that's in, if you want to see the data, make sure that this show tab is selected for all the curves you want to plot. Click plot, and there they are. So that's interesting. Actually, I see immediately that maybe we did a slightly different, we must have selected something slightly different as the export duration for these two files, or the pre-ring duration. Anyway, that's kind of helpful to see that that's what happens. In any case, you see two impulse responses that are basically the same. The second one is slightly earlier in time because we must have used a shorter pre-ring number than we did previously. So that number there must have been shorter than for the second run. The second run here being the blue curve, curve 1. Anyway, you can see that plotted nicely there, and the frequency response here is not particularly interesting. It's basically flat. So if you click reset view here, it will, maybe you've been panning around, for example, having a look what's going on here. Click reset view, it will set all the axes limits according to these numbers here. So by default, linear log magnitude here is selected, which means it's log. So this is in dB, and linear log frequency is also selected. So this horizontal frequency axis is linearly spaced. If I wanted to change that, I might just deselect those, in which case I get linear frequency and linear magnitude here. And again, I see something that looks pretty flat. You may be interested to do something similar. Let's just replot that. Like that. You may be interested to see that you can do the same thing in time, which sometimes can be helpful. So you can plot the amplitude linearly, logarithmically rather, and you can plot time logarithmically as well, which may be useful in some situations, probably not very often. Okay, so that's pretty boring. Those are not very interesting impulse responses. Let's load some other ones. So I collected together a few, few of these in this examples folder. One of these, I think, this one was sent to me by one of you guys this year. So let's just show you, I want to show you the fact that you can load a bunch of these at the same time, and doesn't want me to select things from different folders. Okay, fine. Let's just do that. Why not? Somebody's trying to contact me. Okay, so by default, then once you click the load button and you've selected your files, you'll get all the metadata from all the files here. So you see for a start that some of these are at 48 kilohertz, some of them are at 96. They get ordered kind of semi-randomly, I think. There's a unique file ID for each file. So this is one file which has one measurement. This is file 2, and all of these data here are file 2. There's a bunch of different microphones here that have been labeled, and this is file 3 with also a bunch of different microphones. Each particular impulse response here, which corresponds to one line in the table, has a unique curve ID here, which is assigned upon import. So let's just plot everything. So if you make sure all of these are selected, if they're deselected for some reason, maybe you click the deselect all, you can click select all and it will select them. Let's just plot them and see what happens. Great, okay, so I left that on by default. Here we go. So here are a bunch of impulse responses and frequency responses. When you've got a lot of curves, it can take a while to replot. So there we go, there's the curves replotted. So I'm not quite sure why these impulse responses have appeared to be so small here. It must be something I'm doing upon import. Let's just fix that for the purpose of looking at it by clicking normalize all to 0 dB, which maximizes the volume of every single impulse response you've labeled to 0 dBFS. So that can be useful. So there they are, you see they're all peaking up plus or minus 1. Okay, so there's my measured responses. Incidentally, you can do the same thing for the frequency responses. Normalize all to 0 dB. They'll shift all the curves so that they peak at 0 dBFS. If you want to see the relative differences between curves, you probably don't want to click that option. So maybe let's do that now. So let's deselect these. And let's have a look at, I don't know, this is a dummy head with a left and a right channel. So if we plot just those two, select them, replot. Let's reset the view. Okay, so this time is too short here. Right, that's why it wasn't appearing. So these are left and right channels of a binaural head in where? St. Cecilia's Hall. So you see the frequency responses here. You can select the zoom tool, have a look in. You see the really interesting differences at low frequency, and then you know, progressively kind of more random, like frequency response shape at higher frequency. Obviously, if you click, oh, that's not helpful, is it? Because it's normalized in both. So let's deselect that. And there you see, in actual fact, when they're when they overlay, when they're set to have their native levels, if you like, the levels due to the binaural effects, you'll see at low frequency the curves line up better than they do at high frequency. Okay, so that's the tool. That's basically all you can do with this tool at the moment. You can look at your curves, you can examine them, find the ones that look sensible, the ones that look less sensible, and then maybe go in and do some further processing on your own of those particular files. If you wanted to, for example, take this stereo-like signal with two channels and bake it to a WAV file, all you need to do is select them here, click Export WAV. It will give you the chance to write. So this is St. Cec binaural, and that was where second row center. for example. Click Save. I should probably have some text here that tells you that it's saved, but I don't. In any case, there it is. There's your stereo 24-bit binaural impulse response ready for use in, I don't know, Reaper or some other plugin. There we go. It's written it with probably a bit too long. Wow, that's way too long. Okay, so that's interesting. That must be a holdover from, because this is an old file. So it's a good chance to show you that you can customize the duration of the impulse response on export. So this is written a 40-second impulse response, which is way too long. Let's go and have a look here in Audition. So 1.5 seconds is plenty, probably much more than we need here, but we'll use 1.5 seconds. So if we go back to this pane here, click the Truncate IR button, we'll go up to only 1.5 seconds here and start at 0. Let's click Export again. It will give me another pane. I'm going to select that file, delete the extension, save, replace. Let's close that. So that should be, now it's only, duration 2 seconds, which I think means 1.5. There we go, exactly 1.5 seconds. Beautiful. Okay, so that is actually, when in practice, once you get used to the tool, it's very quick to go from a measurement to a plotting to an exporting within seconds, really. There's no further analysis of the impulse responses yet implemented within this GUI. There are some tools out there already that you can do that with. There's no calibration, but that will come eventually when I get the time to do so. Good luck.